Good. Good morning. Almost afternoon, right? We've almost made it there. I know we're supposed to be done here in about 10 minutes, and one thing I'm pretty good at is making up time. So last thing I want to be is the person between 100 hungry people and lunch. So we'll try to make sure we get through this as effectively as possible. As Skip said, my name is Sam Cooper. I'm the Materials Research Administrator at the Department of Transportation in Louisiana, and we work at LTRC, which is on LSU's campus. And for the past few years, I've been one of the people that's kind of the keeper of the asphalt section of our specifications. So in order to get specifications in practice and make sure they're logical and everything, there's a lot of collaboration that has to occur, anywhere from just doing the research itself, getting materials supplied and getting mixtures made and things like that, all the way through making sure that they are effective specifications and logical specifications, right? So there's a lot of logistics that go into it, rather it's not just materials and can we use this or should we use this or shouldn't we? So that's what I'm going to talk about today is our general process that we go through in Louisiana, and then highlight a few projects that were successful, and I think I have at least one in there that was less successful, but we've made some changes to get it there. So every 6 years or so was the general plan for coming out with specifications, and it was kind of similar to what we saw in that keynote address where there's a long gap and then a big change and then another long gap where nothing's changing and then a big change. Well, in recent years we found out that it's not really working that way anymore, and the changes come constantly. So there's always something to evaluate, there's always a new material coming out, and so our spec process is kind of adapted to stay up to date on possible changes and maybe make intermittent adjustments to the spec in between the book printings. Okay, so typically we use the Asphalt Task Force for this. It's head up by our Chief Construction Engineer at headquarters, and basically he pulls people together from industry, from research, from our Central Materials Lab, which is where we do our testing, contractors, QC managers, binder suppliers, and even our owners of the asphalt producers in the state. And everyone comes together usually every quarter, and we talk about how what changes may be coming or what needs to change in the spec, what's not working, and what maybe is working. It's usually very little about what is working and a whole lot about what's not working, right? So the first goal of the meeting is to talk about logistical challenges that they're having. So if something that we put in the spec from the state side without any input from a contractor, if that doesn't work, then that gets brought up there and we can address it. And then after we go through those functionality issues that they may be having with the current specification, then we get into wish list items. Those are new technologies coming out, new processes, changes to how we do the spec that may be working as far as from a logistics side, but there may be something new coming out that we need to start taking a look at. And so once we get that information, then between the Materials Lab and LTRC Research Center, we gather the information on what the changes were. If research is required, we conduct the research. And then once that's been conducted, then we take our recommendations, we get it to our construction group and the suppliers. Again, Skip was mentioning our pavement associations and things like that. We talk to them and start figuring out how to get this in the spec or how to do field trials, etc. Now, this can take anywhere from 3 to 3 months, which I think would be a record time, like world record breaking time, or several years. Okay, and in a lot of cases where if it's a complex change, we're going to have to do a lot of research to get there. And because one thing the state doesn't want to do is put something in the spec that's going to sacrifice the quality or the performance of the material. Right, we're pretty open-minded in Louisiana about potential new additives and things, but if it's going to sacrifice our pavement quality or the performance or the durability of our mixtures, then it's not likely to get off the ground. So I have about 4 examples of changes that we made to the specification that dealt with a lot of collaboration. And the first one is chrome rubber. And we started looking at chrome rubber again well before I was at the Department of Transportation in the early 90s. And it was in a response to a shortage of, the polymers that we had been using. And the contractors and suppliers came to us with the potential to use chrome rubber, as well as the research and everything that we've been reading. And so we conducted the research to see, can we use this material? Is it going to be a viable material for the state of Louisiana? And again, the research started way back in the 90s, and it's currently still changing. Okay, the specifications on rubber are still changing as modifiers come out with new technologies. Every time a new technology comes out, they usually come to Louisiana as one of their states because they know it's in our specification, and we evaluate it. The current specification right now, we've looked at wet and dry processes. We still look at wet and dry processes depending on what becomes available, but the spec currently allows a wet blend. We also have looked at terminal blends versus plant blending. In Louisiana, we do allow plant blending, so either of those is accepted as a chrome rubber modified material. The max percentage that we instituted in the specification when we first put it into the spec was 12%. I think that was in the 2008 spec. And initially, as we've done research and moved on and seen changes in the binder material itself, we've dropped that down to 10%. Particle size is 30 mesh, which is a pretty common specification. And then we've had field trials of both successes and failures to kind of create those specs that we have right here. Like all that is based on lab trials and then carried into field trials. An example of a specification that didn't work out too well was our most recent change to our 70-22 spec, the SBS polymer modified 7022. We did research at LTRC looking at massacre and trying to make sure that we could incorporate this test into our specification. And when we used SBS polymer, it seemed to be all right. But our 7022 isn't all SBS in our state because we're plant blended state. We do allow latex to be used as a modifier, and it doesn't react the same to MSCR testing as SBS did. So what happened when we did that, we basically shut out the use of latex PG70-22 materials. The contractors couldn't get it without extremely overdosing the latex, and then it became a functionality issue through the plant. So it was clogging everything up. The mixture was not flowing well. It was chunky. So we went back and looked. We looked at our history and started saying, okay, we had no performance issues with 70-22 with latex. So why is our spec written such a way that we can't use it? And so we've spent a couple years looking at latex modifiers. I think that might have been a one-year study. Latex modifiers and our historic data of MSCR, and found that where the curve in the MSCR test wasn't appropriate for our 70-22s that we historically had without performance issues. So originally, the 70-22 had to meet the curve. It was the JNR was between 1 and 2, and it had to meet the curve. What came out of it was we changed that. The MSCR test is still required to be run, but it doesn't have to meet the curve if the JNR is between 1 and 2. At 3.2 kPa, it has a minimum percent recovery of 15%. That aligned better with our historic data, and it also aligned better with our latex. Okay, again, everything's related to field performance. If we get the performance, we want to make sure our spec is written such a way that we can include materials that have been giving us good performance. And what came of this was we got a lot of information. It wasn't just the latex. There was also information coming from our asphalt suppliers that produce these in the terminals, with SBS, and even the SBS material was having trouble. They were essentially dosing it, dosing the liquid as a PG76 almost to get a PG70. And you know, in that case, why do we even have PG70 in the spec? We're spending the money for a 76, we might as well just use 76. So we want to have that mid-grade, so we had to find a solution for that. A little bit on the mixture side, we've introduced mechanical mixture testing into our spec as part of our balanced mix design procedures. And this was a very large change that we needed a lot of collaboration to make sure we were keeping everybody that was going to have to use this in mind, okay? So it was going to require the contractors to completely change the way they do their designs. It's not going to be volumetric anymore. And so that required them having to purchase things. They had to purchase test frames, they had to purchase ovens, they had to purchase saws. All that had to be discussed with them so that we could keep them in mind as we're writing the spec, because it's very easy at LTRC, we already have all those things. So we say, oh, just go run it. Well, contractors have to get prepared. It required training. There was requires transparency, because you can't hide anything. You know, you're trying to help the contractors figure out what they need to do. So, you know, being secretive about it doesn't really help. Going to the contractors' labs. We would go to the contractors' labs, help them set up, help them work through the analysis procedures and everything, and then understanding how that would work in a real-time production situation. If they have to go pull mix from the lab, how long is this going to take to get the test result? Those types of things are still the concern. So as far as training goes, we brought the contractors in and our state agency people in, and we did a training workshop, a full-day event on our cracking test. Everyone at this point had been pretty familiar with the LWT that we were using and had been using for years. But when we instituted the cracking test, we had to bring in training for that. So we brought our contractors in, our district personnel in, as well as consultants who may be working with the contractors to make sure everyone's trained up and gets more comfortable. Once that happened, then it became part of our mix design table, as far as cracking and rutting tests are concerned. Right. Another change we've done fairly recently came from the contractors with potential issues with getting density. We pay for our asphalt mixtures based on density. The issues concerning density, we still are a PWL spec, but there were instances where a contractor was just required to mill off 2 inches and put 2 inches back. It's probably our most common form of paving. Well, in that case, there's no base repair, there's no improvement to the subgrade material. So when the contractor would hit a soft spot, through no fault of their own, they were struggling to reach the density, and then that would show up on their PWL, and they would get a pay cut. And so in the interest of fairness and understanding, we took a look at a potential adjustment to the pay table and did kind of a risk assessment to say what are we comfortable with as a state, because we know PWL gives us the most consistent form of density and will generally increase our densities, which we know are tied to better performance. So we looked through, did our risk assessment, and we determined that for ADTs less than 1,000, so very low volume roadways, that we would replace PWL at the contractor's option with a average density spec. So we would just be computing average, and they would get paid based on the average for the lot. Now, the compromise, though, came in, they got a new mixture with that. So they got a new mix design table, a smaller aggregate, 9.5 and 12.5 are the two mixtures that they can produce, and there's more liquid in those mixtures. So on the state side, again, performance kind of reigns king for us, so we wanted to make sure we got density and we didn't have the risk of getting something that was permeable. So we created a mixture that's a little bit more easier to compact, so we can get density higher, easier when they hit these soft spots in the road. All right, so the main thing we try to do, and this might come as a surprise, is we do try to make things practical. It doesn't always feel that way. But we know out of this research comes testing and a lot of ways to measure the pavement that can be complicated. But we want to institute them because they are properly describing what we expect to see from our performance. So we have to make sure that when we put these changes in, that they are practical. And in order to get that done, from an agency standpoint, we need the information to come from the suppliers and the contractors on whether or not they can use this and practically be able to do their job still, right? So that's kind of the why collaborate, right? Agencies own the road. We're the owners. Shouldn't we get to just say what we want in it, and everyone else just has to do that, right? Well, how many agencies own asphalt plants and produce tons and tons of asphalt every hour? Not many. So there's a lot of information that we don't have as an agency that needs to be taken into account for our specifications to be functional and fair to both agency and contractor. There's another one, agencies are the customers, right? We're the ones paying for it, but are we always right? And there's kind of a reduction in pride that has to go if you're an agency. Yes, you're responsible for the roadway. Yes, you're responsible to make sure it lasts long and the taxpayers' monies are spent appropriately, but there are things you don't know, right? I mean, even if the agency fills up with extremely knowledgeable people, there's always something that's going to be missing, and when you can team up together, you can start to identify those issues. So I think in Louisiana we do a pretty good job of taking a look at ourselves and saying, this is what we know, this is what we don't. And it's really important to identify what you don't know so that you can find people to fill in that area of expertise. And that also doesn't mean, just because you know a lot about asphalt mixtures, it doesn't mean you ignore someone else's input just because they're giving you input on asphalt mixtures. You incorporate everything, and it really helps make the whole spec better and more workable. So the main factor I've noticed in the last, 11 years at LTRC, starting from a grad student on to where I am now, is dialogue has to occur. That's been the main driving force to getting changes done, is in the relationship building. You have to have a relationship so that you can talk openly between all the respective parties to make sure changes can be made. Everyone has to have a voice at the table, and that's what Skip was talking about. Our spec committee and our asphalt task force, everyone's in the same room, everyone has the same general goal, which is to discuss the specification. And so we can get that information done, we can process it, and then we can try to make changes. Relationships with the associations are important because that's kind of your bridge between contractors and the agency. They kind of form that bridge, and Louisiana is unique, and Skip alluded to that too. Every asphalt mixture producer in our state is family owned. I've been in a part of the asphalt industry since I was 5 or 6, and they've all seen me go from an annoying little child to an annoying larger child. So it's easy to have that communication, but if you're in a state where that's not possible, then you have to rely on the relationship with the pavement associations. All right, as far as what's next, and this comes from information in nationally as well as the CPUG group, as well as DOT, what we're looking at individually is, and you've heard it about 15 times probably in the last 2 days, is plastics and asphalt. We're obviously going to be looking into that, doing research in that, whether it's state funded or federally funded. It's coming, and we're going to be looking at that. That's a potential change to the spec, that if it's successful and we can maintain performance, we will use it. High polymer, high doses of SBS polymer or other polymers in our binders is something else that we look at from time to time, or I know it gets brought up a good bit. The main thing is we know we can use it, we just have to find a spot to put it that's practical. Low temperature binder testing, being in Louisiana, we don't have a lot of issues with low temperature. I think 2 days ago it was 80, but it's been raining for 2 months. So not quite the same as here. But we are starting and continuing to look at research there for potentially replacing current performance grade testing. Okay, so new low temperature binder tests that would replace certain things. So contractors need to be involved there, material suppliers need to be involved there. And then again, our specification isn't we print the book, it's this for the next 6 years, we print the next book, and that's how our changes are going to work. It's turned into a living document that's just constantly being put under a microscope and evaluated for changes. And it's a good thing we're in a digital age because we can always update that. And I think with that, that's all I have for you. And that's a picture of LSU's campus in the spring, so that's coming up. And I'll be like Coach O and say, "Go Tigers," when I'm done.